right, good afternoon everybody. My name is Johannes Urpelainen. I am the director and Prince Sultan bin Abdulaziz Professor of Energy Resources and Environment here at SAIS. And I'm very glad to kick off our seminar, the Initiative for Sustainable Energy Policy Research Seminar with Will Checkley. He's an MD, he's a PhD, he's a professor, he's a practitioner, and he's going to tell us today about LPG stoves and fuel distribution, health issues, air quality issues, lots of interesting stuff. And Will has a background in economics, so the way we're going to do is Will is going to just walk us through his presentation, and you feel free to jump in at any time if you have questions. In economics, we usually know that if you get through the first slide, that's a pretty good achievement for an econ talk, so we'll see how it goes. Will, floor is all yours.
Thank you very much, and thank you for inviting me to talk here at SAIS and have an opportunity to kind of interact with different faculty members in the university. I think we could use this as an opportunity to identify potential collaborations, ideas, and so forth. And I'm going to be talking specifically about the interventions that we've done in Peru as a way to mitigate household air pollution. And it's not only Peru, but also in a couple other country settings. But just as a disclosure, we're lucky to being funded by the National Institutes of Health to do this work, and we've had a good amount of support from the Hopkins Center for Global Health. But in one of the projects is a joint initiative between the National Institutes of Health and the Bill and Melinda Gates Foundation. And there are being other groups, in particular the UN Foundation through the Global Alliance for Clean Cook Stoves, that now is called the Clean Cooking Alliance. I mean, they just recently changed their name. This work doesn't have this work is international collaboration. We have partners in different countries, and in particular in Peru, we work closely with the university, with Universidad Peruana Cayetano Heredia, and with a non-governmental organization, Asociación Benéfica Prisma, who help us with all the way from research collaboration to logistics, administration, and project management. But I'll also be talking about our four-country project where we have collaborators from Rwanda, from Guatemala, and India who are included in this slide. So as I said, I think the objective of the study is twofold. I'm going to just discuss the two ongoing liquefied petroleum gas stove and fuel distribution trials. But I wanted to use this talk as an opportunity to discuss opportunities for collaborations with ISEP and see if there are ideas here that resonate with you that we may not, we as epidemiologists and as physician scientists may not be as in tune as you are. But I think this is the main problem, and I think it's. How many of you have been in homes where they cook with biomass fuels? So as you know, I think it's this is a gross exposure. Once people are burning wood or burning dung or agricultural crop waste, what you see is exactly what you see in the photograph. Haziness fills the room. The smoke permeates everything. In just a couple of minutes being in there, your eyes are itching, they're irritated. So it's a good amount of smoke. Here, this is a picture we took in Peru. This is like a woman using a traditional wood burning stove. Here on the right, you can actually see some of our air pollution monitors that we've used to measure. But as I said, this is a gross exposure. So once you burn wood or dung, you get smoke everywhere, and then also the soot goes everywhere. It's up in the walls, and this is kind of a traditional hearth. You can see it's made of adobe, and there's the chamber where you put in the wood. But I think the main thing I wanted you to take away from this figure is just kind of the exposure. You can see it, that it's everywhere. It's around the hearth, it's in the walls. And it gets to be so extensive that it just accumulates as stalactites in ceilings. So all of this soot and smoke is also being breathed in by the people who cook. And this leads to significant health problems throughout the life course. And this is an important problem. As you know, this is a prevalent condition around the world. Currently, it's estimated about 40% of the world uses biomass fuels for cooking and heating. And in rural settings of resource-limited countries and low and middle-income countries, this gets up to be about 90% of rural homes are still using biomass as a source for energy. And as you know, the use of fuels, biomass fuels, is directly linked to GDP. And in this analysis from the World Bank, they looked at a whole series of countries, looked at the GDP per capita, and linked to the percentage of households using biomass. This was updated from DHS-based data, and there's obviously a straight line of resource-limited settings cannot afford higher grade fuels. And you're all very familiar with this energy ladder. You know, just when you're resource limited, you're going to burn what's free. You know, but what you burn is also not only low in production of energy, but is also, because of its nature, it leads to incomplete combustion and produces toxic fumes. So obviously we want to be up here. We want to be up in the electricity and natural gas zone, but in many of the settings where we work, we're kind of in the very low income and low income settings. You see crop waste, you see dung, you see wood, and all of which produces a good amount of smoke and environmental hazards. The good thing is that the world's getting less poor, and we've seen this throughout decades, and in particular in Latin America, there have been great strides in getting out of poverty. And in many settings in the Americas, the exposure or the need to use biomass fuels has decreased dramatically. Now it's estimated it's about 14% in the 2000s compared to about 40% in the 80s. There's been much less movement in Asia and Africa, however. You can see that it is still quite prevalent. There's been some reductions, but in some Southeast Asian countries, this line is as flat. A lot of this is driven by China and India. But you know, once you leave China and India.
Southeast Asia, South Asia, and East Asia, how does it look?
I'm sorry?
If you separate the Southeast Asia,
exactly,
South Asia, and East Asia.
Yeah, we have to. I bet you that the South Asia is actually has much less of a change compared to the more developed countries in Asia. So this is a big problem, and not only is it a prevalent condition, but it has important effects on health. The estimates from the global burden of disease is that it is responsible for more than 4 million deaths and about 100 million disability adjusted life years lost due to these exposures. And women and children are the ones that experience the most, and it's estimated that household air pollution is associated with about 5% of the global burden of disease. So this all led us to become interested in trying to better understand this topic. At the time, I was conducting a longitudinal study in Peru. We were following about 3,000 adults in 3 different settings, and we began exploring this. We were really interested in understanding how important of a problem this was in our settings, and we had a chance to do a couple small studies and a couple surveys. And Susie Pollard, who's here, spent time in Pune doing this. I think one of the first studies that we did was just kind of trying to understand just kind of household structure, household construction, and how it's related to exposures. And I think one of the easiest things for pollution is ventilation. So they say that the solution to pollution is dilution, I guess, within the house. So if you can vent a lot of the smoke exposures out of the house, then you can resolve some of the problems within the house. Obviously, it doesn't solve the ambient problem, but we just basically went around. We at the time had been conducting census surveys. At the time, we had followed about 4,000 households. Now I think our area in Puno, we covered closer to about 30 to 40,000 households. But at the time, we just kind of separated into urban and rural households, and we try to understand that, in the adaptation in Puno was that many of the houses realized that this is that cooking with biomass is a injurious and hazardous exposure. So they separated the kitchens from the home. So you actually go in Puno, you'll see that there's like the main living area, and then there's the kitchen area that's a separate structure. And we found that this was pretty common. Close to 90% of homes had a structure that was separate from the kitchen, and those that had a kitchen, very few actually had a chimney. We found that it was maybe 1 in 5 that had a chimney, but the majority did say they cooked in rural homes, that they cooked with open fire stoves. And we also thought it was interesting that few of the homes that had worked on, had heard of the national program for improved stoves, or even the energy fund at the time.
You're urban or housed urban?
Pretty urban.
The urban residents are people who have residence. They're not homeless urban.
Yeah, no, it's not homeless urban. So we just
Homeless urban.
yeah, and I think I don't have pictures here, but urban Puno, Puno has about 150,000 people that live in the city, and it's a pretty urban environment. I think most of the people living in Puno have access to natural gas or electricity for cooking, and it's and most of them work in services, whether it's for private companies or for the government. So it is more of an urban living as you expect even in Lima, which is the capital city. The rural settings are quite different. So in this particular study, we said we were interested in seeing what happens with the exposures, and this is our first entourage into understanding the exposures. So here we actually did measurements of particulate matter. We used a device that allows us to do kind of real-time assessment of environmental exposures, and in particular, it measures particulate matter, fine particulate matter. And we were able to record over a 24-hour period. We also did extensive validation of this device, because we want to make sure it's actually measuring what it says it's measuring. So Susie spent a lot of the time in kitchens. To be able to validate it, what you have to do is actually collect the particulate matter over time in a filter. And what you do is you basically have an air pump that collects the exposure in the filter, and then you weigh it. You weighed it before and after, and you know how much is being accumulated. And you make an estimation of how much concentration there is in the air. What we found is that these filters would get filled so quickly because the exposure was so substantial that we either had to make changes to the way that we did the airflow, or in the case of Susie, she actually was in the kitchen every 20 minutes switching the filters so we can make adequate estimates. So it was a pretty intensive measurement. So here, so what these plots show here, you have the left and on the left you have, we went ahead and calculated average hourly concentrations inside the homes across these different hours, and then we just took the median of it. And on the right we looked at the maximum hourly concentrations in the homes, and we just took the median of that. The red line is the measurement that we did in urban homes. And as you can see, the urban exposures, you look at the average hourly indoor concentrations, the median is pretty much below 25 micrograms per cubic meter, which is what WHO says is clean air, safe air. It's under the WHO Code of Guidelines. But when you go ahead and you look at the black lines, which represent the exposures you're seeing in rural households, you can see that the exposures, especially during cooking, you're experiencing an average exposure that's 10 times the safety limit determined by the WHO, which is about 250 micrograms per cubic meter. And when you actually look at the maximum exposure, these values can get up to 1,000 micrograms per cubic meter.
Peru?
This is in Peru. In Peru.
What
So
about during the peak hours outside the house, what does it look like?
it looks like the red line.
You know, in rural?
Yeah, it looks just like the red line.
Oh, really?
It's quite low. I think usually it's a 25 microns per cubic meter. I think.
When I think of India, urban areas.
It's very
peak
different
hours.
because, and we'll get to that in another study. I think in Peru, the density, the population density in our zone in Puno is about 20 per square kilometer, and houses are about a football field of separation. So again, solution to pollution dilution. You have enough homes that are separated. It will quickly dilute, and then that's why you don't see major increases. It's very different than what you see in India, when you have densities of maybe 1,000, 1,200 per square kilometer, and everybody's cooking with biomass, and then you'll see kind of increases in ambient air pollution in relation to cooking. For this, kind of the main takeaway of this is if you actually look at homes that have or have a chimney or don't have a chimney, there's no difference. Whether you look at the particulate matter, and here, again, we did the same thing with carbon monoxide. We had a real-time device that measured carbon monoxide, and we summarized this every hour, and we did the median of the average concentrations in each hour. And you can see that it's pretty much non-existent in urban households, but in rural households where they burn biomass, you can get up to about 8 particles per million. And it is kind of a pretty significant exposure during cooking time, so without any differences between kitchens that have a chimney and those that don't have a chimney. So I think this was kind of our first entourage to try to understand exposures. We know they were high. They're several times higher, like a good factor of 10 to 20 times higher than what the World Health Organization says it's safe. And then we also know that simple interventions like building a chimney was not working, and we were trying to figure out why. So one of the things that we did is, because Susie had a small enough sample in rural homes, she was able to go back and get an understanding as to why this was the case. And a couple examples where you had chimneys where the chimney would go halfway, and then there was it would go right into the room, and then it continued. There was a gap in the chimney. Other ones where they went all the way up to the roof, but didn't go through the ceiling, but didn't go through the roof. In other, there was a beautifully designed chimney, but there was a window, so whenever there was a draft, all the smoke would come back in. But the majority of them had a problem with the height of the chimney, so there was never enough draft to be able to pull it. So then it became an issue of technical assistance. When you ask people as to why, when they built chimneys, there was a program, the government program that said, clean air is good, so build a chimney and we'll give you there's an incentive for people building chimneys, but there was no technical assistance to be able to get people to build chimneys appropriately. So it was kind of one of our first entourage, and one of our first studies that we did in household air pollution in Peru.
Sorry, the last slide.
Yeah.
So why this pipe about 1 o'clock there? So does it have to do with on the Auburn, the red line? On the Auburn,
Yeah.
this pipe.
Yeah, there's a little at noon.
Yeah, does it have to do with anything?
I have no idea. It's so small. It's so insignificant. It's only like 1 particle per billion.
Sometimes the stoves would actually lead to a spike in the gas stoves that were used in urban, and there might have just, I think probably the ones that had some like technical problems with it. I remember there was one house that had spiked really high, so that probably just led.
Yeah, the cooking
when they're
lunch.
cooking lunch.
Yeah.
Yeah.
So National Institutes of Health, at the time we were funded by National Institutes of Health to set up this cohort in Peru, and we were able to get a supplementary grant to look at thinking about cook stoves. And at the time, it was in vogue to say, yes, I think we should think about more efficient chambers to be able to burn the fuel. The idea is that, well, you're using these traditional hearths that are inefficient, and that they just go ahead and produce a lot of smoke because of the incomplete combustion. If you had a more efficient chamber, then you consume the fuel much more, and then you prevent smoke from forming. So we drank the Kool-Aid like everybody else. Said, okay, yes, let's go ahead and let's do this. And we did this feasibility intervention trial, and we spent the time thinking about this. The organization that we work with, Prisma, had been certified by the government to install improved stoves, and the government has a testing program that looks at the stoves that are built. And in the laboratory, it was up to 98% efficiency in reducing emissions. But then it's a lot of work to actually build them locally. So we said there's also some commercially available stoves, and there were several U.S. and European companies that were making these portable cook stoves, biomass burning stoves, that had a very efficient chamber, and then you can connect a chimney port to it. So we said, let's go ahead and let's do a study, let's do a trial, and have 120 women. We did it in 3 countries, in Peru, Nepal, and Kenya. Let's have them test it out. And we wanted to grab a whole set of geographies to see if this it goes across cultures. Does it, because different cultures cook differently, and we wanted to see if this is equally picked up and what effects it would have. I think everybody, the way we did it was like a crossover trial. So we followed everybody for 4 months with their biomass burning stove. At the end of 4 months, we went ahead and we randomized them to get either the commercially built stove with the chimney port, or the construction of a locally made improved stove. And then we did that for 4 months, and then we crossed them over. So the ones that had the commercially built stove, then we built them a locally made stove and asked them to cook in that. And then the ones that had the locally built stove, we asked them to cook in the commercial stove, and we built the chimneys and all that. So that's how we did it. And we had all kinds of measurements. We're actually we're doing assessments every month. Particular matter, we only did assessment once during each 4-month period, because of just the complexity of the devices and the cost of getting this out. But one of the things that we found out, and this is kind of this is a glorified bar plot, and basically it shows very similar to what you were seeing before, but instead we kind of categorized it in terms of levels. The redder it is, the worse it is. Like the really red is about 1,000 micrograms per cubic meter. Green is where you want to be. And this just kind of like looks at the proportion of minutes that you are at kind of these levels. And this is here kind of in each row is a country. I think the thing that you get out of this is that we were able to reduce the exposure by 50%. So the particulate matter dropped by 50%. From like about, I think it was like 1,000 to about 500 to 600. But do you actually see a difference in reduction? The peaks were not changed. The exposure was still pretty significant. And we went from really bad air quality to just still really bad air quality. Because we even though we dropped a factor of 50%, we were still about 20 to 30 times higher than what the WHO considers it to be a safe value.
What's the difference in Kenya why is so much burning in midday in Kenya?
So Kenya cooks 3 times, and they keep the stove on. That's why Peru and Nepal, they cook 2 times a day. That's one of the things I discovered. And you can see here in the Nepal figure, there's a little bit of green in the middle. I think that was just a technical issue. For some reason, in our Nepali settings, we couldn't get these devices to work for all 24 hours.
Nepal's a much colder country. Would you expect the stoves to be on more?
I'm sorry?
Nepal's a much colder country than Kenya. Would you expect the stoves to be
So
on?
actually, Peru is colder than.
Okay.
Actually, no. I think Nepal and Peru are equivalently cold. I think what's interesting is that people adapt as well, and they don't actually use the stoves for heating as much as you think.
Or just providing hot water or stuff like that?
They boil the water, all that, but they're not in front of the stoves, and that's something that you just don't see it that often. And as you can see, there is some burning, but it was not substantial. I think there's also a lot of the communities in Peru and Nepal, and even in Kenya, But Peru and Nepal in particular, they're like farming communities, so they wouldn't come back home at noontime. And I think a lot of it's reflected in that they would just make a meal in the morning, and then they would go out to the fields or with their cattle or with their livestock. They would just go out and wouldn't come back at the evening, and that's I think why you see the two peaks. I think that those are kind of the differences. But the main message from this is that the intervention really didn't reduce exposures. Peaks are just as high, even though we were able to cut it by 50%, it's still really bad air quality. And I think everybody that was doing research at the time in cook stoves had kind of the same results.
Yeah.
I think we're all talking about the same thing. All the efforts is like, well, while we achieved some important reductions, they still were several times higher than the WHO guidelines. And that there was no evidence that this would actually lead to improved health outcomes. If you think about how is it that you look at the curve of exposure on the x-axis and health outcomes, the y-axis where, and I could draw it over here. I'm just going to use this board. Most of the exposure response type curves look like this. This is higher exposures, and this is worse health. And pretty much all the outcomes look like this. They kind of like either curve a little bit or they kind of continue linearly, one or the other. So as the exposures get greater, you can just see worse health outcomes. So if we're on this side of the curve, let's say you're here, and you shift down to here, then you can see there's very little change in exposures. You really have to try to get it down to somewhere in this area, which is somewhere at between 0 and I'm going to say 50 to 75 to actually make a difference. So this is like, matter of fact, I think the WHO was so frustrated with the interventions that were happening in clean air that they even said, well, we have our cutoff at 25 micrograms per cubic meter. Let's go ahead and shift it a little bit. Okay, let's get it to 37.5 micrograms per cubic meter to see if some people can make that. So this is like kind of the thinking that was occurring at the time in terms of exposures. So there was like limited evidence of exposures. So at the same time, as I mentioned, I think places in Latin America, like Peru, have gone a very rapid change in their economy. Peru's actually moved from being kind of a low income to middle income. And Peru is actually a middle upper income economy. But when you go to rural places, you're still in very low income. So there's a lot of disparities. The rural settings are very low income. So we had an opportunity in this. Susie Pollard, who is an assistant professor at in the School of Medicine, had an opportunity to do an evaluation of existing energy subsidies in Peru. This was part of the Implementation Science Network. Have you guys heard of the Implementation Science Network before? I think you're part of it.
I'm not part of it, but I'm aware of it.
Okay, so and I think that they funded this a whole series of different case studies. We were lucky to get one of these grants, but I think what it really allowed us is to look at what's been happening. Because when we did that original study in Peru, electricity wasn't still there yet, no?
No.
It's amazing that in about a 10-year period, I think maybe 20% of homes, rural homes, are electrified. By the time we were going back to doing our larger trials, 80 to 90% of rural homes are being electrified in Peru. You can light a light bulb. You can't light a stove, and you can light a radio, but you won't be able to keep a refrigerator going. But at least there's some electrification that's going on. So there's been kind of a big change in terms of tackling poverty. And the Ministry of Energy and Mines at the time said, we really want to encourage people to use cleaner sources of energy. And our kind of the programs that we set up to do improved cook stoves were a failure. We know that. So let's figure out other programs. And they started this pilot program that was called the Fund for Social Inclusion for Energy. And it's a kind of a multi-component initiative. And there's many approaches to increase access to clean energy. And one of them was this LPG fuel access promotion program. It basically, what it would do is that it would identify families that were poor or extremely poor, and they had certain criteria to do so, and they would provide them a voucher that would allow them to get about half a tank of gas. So tanks of LPG gas are about 20 kilograms. They're about $10, and this would pay for about half of it. So this is and it's a way to be able to promote adoption of stoves and get it, try to see to get it to be sustainable. And who benefits from this? You either you have to have less than a $6,000 per year income as a household, have no electricity or have some electricity but your average consumption has to be less than 30 kilowatts per hour. You have to live in precarious housing with no running water, adobe walls, thatched roofs. And then there's also a governmental agency that helps to classify households that's extreme or I don't know what happened there. It's extreme poverty or so like there's a registry they keep, so you have to be kind of in that extreme poverty category. So I apologize for that typo. And then the other thing is that you needed to have an LPG stove in your home. So because they're not providing the stoves, you have to make the investment in having the stove. You have the stove, and you meet this criteria, you will get the voucher.
Do households need to meet all of those criteria, or just some of them?
I think they do need to it's a checklist. You need to go down and meet the criteria, all of them, to be able to class.
How many such households exist?
It's actually so we did this in evaluation. I could pull up the numbers, but it's about maybe 20 to 25% of the population. Yeah.
That's just very interesting because in India, almost everybody has electricity. There's a lot of people who don't have an LPG stove, so that's now changing.
Yeah.
I just find it very interesting that so many people can meet all of these.
It is interesting, yeah, because I think what it is, it's like, we've seen it in different programs. I think they know that they're getting an economic incentive out of it, so they'll invest. And most LPG stoves are not expensive. You can get an LPG stove for $50, $40, which is an investment for a poor family, but it is in a setting like Peru, it is approachable. I think of it, you're spending $10 of fuel a month. It's so this is like spending $40. You can actually get them for cheaper, maybe even $25. But they're bad stoves, people can get them. So obviously, a couple of things that what is it?
It's about 1.6 million.
Yeah.
households.
So in terms of existing energy, in terms of this program, a couple of things that we found out when we were doing the evaluation, and we went and kind of looked at all the beneficiaries and so forth, and this program is being run by energy distributors. So of course the energy and the way that the Ministry of Energy and Mines program did it is that they subcontracted the program to a third party, to these electricity distributors. So of course, most of the beneficiaries ended up being those that had access to electricity, because that's how they hear the program. Fewer that didn't have electricity were accessing it, but not as commonly as those that had electricity. The other thing that we found is that we were able to actually do sampling of household air pollution in the homes, and we looked at beneficiaries and non-beneficiaries. And while the beneficiaries had a little bit of a lower concentration of particulate matter in their homes, they had similar. We actually were able to have them wear a personal exposure meter to see how much they were exposed to. They had similar personal exposures, but in both settings, whether it was kitchen or or personal, they were still pretty high, 2 to 3 times higher than you would expect to be the safe level. So they don't really matter. You reduce things, but again, you were still at pretty high levels. And I think what we ended up concluding out of this is that the program was really good at doing initial adoption, but the funds were not sufficient to actually have sustained use. So people were still mixing up fuels. They would use their LPG most of the time, like sometimes, but most of the times they were burning biomass. Anything else?
Yeah, because of that, the exposure levels were not.
Yeah.
What kind of maintenance expenses go with the stove?
I'm sorry?
What kind of maintenance expenses go with the LPG stove? Obviously, the valve has to be
So the tubes,
cleaned.
the tubes actually had to be changed more about every year. So the tubing tends to break, tends to loosen, I think that's the one that's the biggest change. Yeah, you have to do cleaning and maintenance, but I think the biggest thing is the knobs, especially in the poorly designed stoves, will fall off frequently. So
Is this something the owners can do, or do they have to go to the electric company to?
that's depending on the stove. So you're right. I think it depends a lot on the stove. We could talk a little bit about that in terms of what we learned in Chapin Happen, because then we went ahead and started this. We were lucky to get funded by the NIH to run a trial of implementing liquefied petroleum gas stoves in Peru. We're still in kind of we're about 75% done. We're almost done with the study, and here we decided to do a randomized control trial where we take homes that use biomass predominantly or daily for cooking, and we needed to burn biomass at least once a day, and we kind of randomized them to either continue doing what they're doing or get an LPG stove. And then we told them that for the first year we provide them all the fuel they need to cook, and we'd be going to their homes and switching the
Just a quick
the
question.
stoves. Yeah.
Were the meters actually used just indoors or indoors and outdoors?
Indoors and outdoors. So but they used it for a 48-hour period, and then we're able to calculate a 24-hour exposure period.
Okay, but were there like large scale burning around the environment, say, maybe farms or something like that to contribute to the high levels?
It could happen, but then that tends to be a seasonal issue. So I think it's you capture that during seasons, and again, I think homes are pretty separate. I think like any kind of burn pit, you're gonna get some exposure that is significant, but it becomes that those either become a seasonal or actually it's more periodic. Sometimes it's 2 to 3 years, because you're just gonna rotate how you burn. So it's not every time, do it all that often. It's not like the exposures are that frequent. So we've been working in Puno, Peru, that is in the southeastern part of the country. It's at the edge of Lake Titicaca, and Puno borders with Bolivia. So right there, it's in the southeastern part of the country. It's pretty high up. It's about close to 4,000 meters above sea level, and you can feel it. It's an extreme environment, and it kind of reminds me, as I always tell this to people, it's like when there's the rainy season and there's the dry season. When it's dry, it just looks like this. It's like yellow everywhere. It looks like Mongolian steppes. And when it's raining, it looks like Scotland. It's all green, and instead of fields of heather, you get fields of quinoa. They're all like these like purple flowers all throughout. So the Cardiopulmonary and household air pollution trial is NIH funded. The Global Alliance for Clean Cook Stoves also went ahead and funded an ancillary component of the study. This is an area of our study population. We ended up identifying about 400 homes that we would then just randomly go and and select them to participate in the study and then randomize them to receive the intervention or not. We did, the objective was to see if we applied this LPG stove and fuel distribution program, would it reduce household air pollution to any meaningful level, and would it have any impacts on cardiovascular and pulmonary outcomes. And in particular, our primary outcomes are blood pressure, and the respiratory was looking at peak expiratory flow, which is a measure that's commonly used in occupational studies, just to look at it. That basically means what's the peak achieved amount of volume you can get in a particular time. So it's like it's the flow of air you get in the peak flow of air while you're expiring. And then we looked at a respiratory symptoms questionnaire. But we had a whole suite of cardiovascular and pulmonary outcomes, and also beyond the cardiovascular and pulmonary. Not only did we look at real-time assessment of cardiovascular function by looking at your carotid artery. You can actually measure the thickness of the carotid artery. That's like a measure of atherosclerosis. You can do that over time. You can look at how your arteries respond to an insult. What you can do is like when you kind of grab somebody's arm and you squeeze the artery and you let it go. If you have a healthy artery, it will open up really quickly to allow blood to go in and do its thing. But those that are less healthy will like be more sluggish. It doesn't open as much. And you can measure it. You can all measure that with an ultrasound. We also looked at quality of life. We looked at different quality of life metrics. We also looked at nutrition. I think this was particularly important because one of the biggest things that we struggle with these type of studies and interventions is that it's not only a air pollution intervention, it's also a socioeconomic intervention. We're giving them fuel, and that is cost money that they would otherwise not have to spend, and also the time that they don't spend having to collect fuel. They can use that time or the money to do something else. And one of the things that we thought is that maybe a lot of what we're doing is mediated through better eating. They kind of like just change the way they eat. They eat more protein. They eat more or less, less salt or whatever. So we thought that we also measure this to see if the intervention would have an effect. And then of course we wanted to make sure that we were doing the right thing by giving this intervention. Were they actually using it? So we actually put monitors on stoves, basically little temperature meters, that whenever you turn on the liquefied petroleum gas stove, it would log the uses. And we also put thermometers in the biomass stoves to see if they used it as well. So we were able to monitor use of the stoves.
How much of their income goes to purchasing biomass fuel when they use biomass? How expensive is the biomass for them?
So again, for most of these rural communities, it's all free. So in Puno, they collect the dung, they dry it, and they keep it, and people have these depots of dung that are about this size. They fill up half a room full of dung, and that's their energy. Wood is also something, they use wood as well, but Puno is almost above the tree line. So there's only certain trees that are available, like eucalyptus trees, or they go lower land and be able to bring wood up.
How does the biomass combustion change from dry season to wet season?
It changes dramatically. I think there's much more incomplete combustion in the wet season.
Yeah, it must be pretty poor.
Yeah, so that's the one thing. So this one study, yeah.
So medically, do you see the medical changes in terms of various outcomes in the wet season, dry season for people who use biomass?
So that I don't think anybody's looked at it by season, but it's pretty clear that as the exposures go up, that you get higher blood pressure, you get more events, you get higher chances of people developing chronic obstructive pulmonary disease, so like chronic respiratory conditions. More people get chronic bronchitis, which means more phlegm and cough, or exacerbations of chronic pulmonary conditions. It's also linked to lower birth weight, just like maternal smoking is. Like the smoke itself is inflammatory, it leads to lower birth weight, and it increases susceptibility in children by just inflammation of the lungs just makes children more susceptible to the pneumonia. These are kind of the main links that air pollution has. So in this particular study, we followed 180 participants. We randomized them half and half, and we followed them throughout the year. We did sequential measurements throughout the year, and then in some we had, like in some of the assessments, we just did it at baseline and end line. And we have kind of a whole set of eligibility criteria where we're like looking primarily at the primary household cooks. They have to be anywhere from 25 to 64 years of age. They didn't have to be moving around. We wanted to make sure that they were actually living at their home for more than 6 months. They didn't plan to move. And that they had at least they burned biomass once a day for cooking. And we excluded anybody who was pregnant, anybody who had hypertension or had a chronic lung condition like COPD or tuberculosis. The thing is, and this is something that we wanted to also touch base. I think we broke up the trial in two. We had in the first year is a standard efficacy trial, which means that we have these intervention homes and control homes. They're randomly assigned to get the stoves, and those that get the intervention get the stove and all the fuel they want for the entire year, and then the control homes continue to use their traditional stoves. So that's that's kind of the design. We're looking at efficacy, and then because this is an intervention that's going throughout the whole year, then we are able to measure the reduction in exposure, if there's any, and then measure differences in clinical outcomes. The second year turns out to be an interesting year, and we're in the midst of the second year, so we're going to be done with data collection the second year in February of 2020. So what we did is, we know that this is a socioeconomic intervention as much as it is an air pollution intervention. So we said, we can't not give things to the control household. So we said, we promised the control household, we said is, we're doing this study in 2 years. In the first year, the intervention homes get the stove and the fuel, and we'll go to their homes and we'll install the fuel and we'll keep it running continuously. In the second year, we told the intervention homes, we stop delivering fuel to you, but we're gonna still come to your home. And we're hoping that after a year of use, that you will see kind of the value of it, and then you continue using it. But we're still gonna monitor everything. And then that will allow us to look at how many people actually made a behavioral change and decided to just cook with LPG, and actually how many people had to go back to burning biomass. But the control homes, we told them, so the control homes in the second year, they got the stove, a free stove at the end of the second year, and we gave them, we also gave them the fuel for free. But it's a little bit of a different setting. Now they have to actually go and pick up the fuel at one of the distributors. And we mirrored the social inclusion fund approach, where you get a voucher, and that you get this voucher to go and you go to the store, and instead of paying half of it, you get the entire LPG tank. The main thing that you need to have is an empty LPG tank. And so that's kind of, we thought that this would be kind of this would work as an effectiveness type trial. Well, you're removing monetary issues, or you're removing the issue of money. Now you're looking at logistics. Here you can actually see in blue are the LPG stores, and in black are all the the households in the area. So for some, it's only a 10-minute walk or a 20-minute walk to get to the store. For others, it could be you're at the top of the hill and you gotta somehow get all the way down, and not everybody has a car and they have a bike, or maybe they have to pay a taxi, maybe they have to get a neighbor to drive them halfway or to their home. So there's other logistics that play a role in how is it that they access their fuel. So we thought that this would measure, other barriers to access other than monetary incentives. So this is how the study was conducted. So the intervention, you can actually see the intervention. It's we got this 3-burner stove, and we did a lot of research because 3-burner stoves don't exist in Peru. There's only 2-burner stoves or 4-burner stoves. But when we went to the communities and we did all this formative research and we asked them, so what kind of stove would you like? They said, we want 3 burner stoves. So, but we said there's only 2 burners and 4 burners. Well, no, but we want 3 burner stoves. So we went to a manufacturer and said, can you build us a 3 burner stove? So this manufacturer built us these 3 burner stoves that we got. That's the cool thing about doing this formative research is you get to see what helps participants use the products. So we built these 3 burner stoves, and we were able to get them to enough of them, and also have some replacements. We initially, this is kind of the foresight of things that you don't think about. We said, well, we got the stove, and we told people they have to have the stove elevated because there has to be a difference between the LPG tank and the stove. So the first couple rounds, people were just putting them on the ground, or they were kind of like put on top of rocks, and they were uneven. And we said, well, that's not going to work. So we ended up having to buy a table as well to make sure that it was elevated enough so that they could cook. So we went from this to this.
Not a pollution question, more of a cultural question.
Yeah.
Did you ever look at, was it a change from biomass cooking to gas cooking, produced changes in what people were cooking? I.e. gas cooking probably gets you more, so you can do sautés things.
Yes. So
and
we
stuff
did,
like that.
as part of our nutrition data collection, did 24-hour recalls, and we did 3 24-hour recalls, and we did it at 4 different time
And was
points.
there much change? In what people
So
cook?
the answer is no.
No? Okay.
So the answer is that we didn't see any change in the way people cooked, and there was no change in terms of the content of protein, of carbohydrates, or fat. It actually remained the same. So we were like, well, oof, luckily it didn't. Whatever we're finding will not be related to diet. So that's the thing. So this is basically, this is on the day of the intervention. You can see the women that got the intervention stove. They were all happy. Everybody's always cheerful. The control households are always upset. They go home, they're kicking rocks, and they're upset, and then get selected. We actually ran into problems with this because by the 3rd round, the community is like, this is rigged. How come this household gets it, we don't? And this is totally rigged because you're giving us this envelope. Because we have these sealed envelopes where we have the randomization process. And how do I know that you're not giving me like a rigged envelope? Oh, so that became a hassle. So we had to we took a hat and we grabbed all 15 envelopes and we shook them in. And then people had to actually pull the envelopes to make sure that they had the choice of choosing an envelope. And that eliminated that issue. So that was a big issue in terms of how is it that you design studies. And so anyhow, we ended up having to become a gas company because we had all these like gas tanks, and we had our guys in motorcycles. These are all empty tanks, so they're not full tanks. Otherwise, that'd be a liability. But we have these guys in motorcycles would go around, and they could carry up to 4 tanks of gas, and they would go up and down all that map that you see delivering fuel. And that's how we got it done. And we have all this suite of different environmental devices to measure particulate matter, the ECM, the CO, and the LASCAR, and air quality. And we did put them in the kitchen, and we also had people wear them. And, we have actually a couple of our students became expert sewers, and they helped us design a vest that would allow us to have pockets and put the meters. And I think a lot of this, and again, I think it's I'm a physician, I'm an epidemiologist, and I think about endpoints. I always think about quantitative values, odds ratios, differences in lung function, relative risks. Bringing in the social behavioral aspect into this is being incredibly important. Understanding the formative research, so collaborating with social behavioral scientists has really enriched the work that we've done. How is it that you actually do focus groups? You try to understand things. We did the Pepsi challenge, so women were like hesitant, I don't know, these LPG stove, things not gonna taste just as good. So we actually ended up running focus groups where we did the Pepsi challenge. It was like, which one do you think is cooked with biomass? Which was cooked with LPG? So they were like, yeah, it actually doesn't taste that bad. You can use LPG. So we had to do these things, to talk about differences in taste and figuring out social norms, safety concerns. Women were deathly afraid of having to turn on the LPG stoves. This thing's gonna blow up. We have not had a single episode of explosions in our study. But safety concerns were a major issue. I think in the first year, the safety concerns were eliminated because our team did all the hookup. It'd be interesting to see how it's gone in the second year as we get more data. And then of course, everybody says it's too expensive, I can't pay for it. It's not real. It's too much money. And then there's like also, we talked about it. It's like they said, forget it. Like, why should I don't have enough money, why should I change my way of cooking to improve my health? Because they just didn't see that as an issue.
You say cooking niches filled by different stoves, what do you mean by that? In the previous, your second one was cooking niches filled by different stoves, what do you mean?
So, you can't barbecue in an LPG stove.
Yeah.
If you want to cook a barbecue, you're not going to use that. I think that's a lot of what they say. There's certain plates that need an open fire. And that's part of some of that cultural barrier that we have to go through.
But biomass really doesn't give you open fire, does it?
What is it?
Biomass doesn't give you a usable open fire.
Yeah, it does.
It does.
It's like an impressive open fire. At the end of the day, I think one of the issues that we found with the improved biomass stoves was that they're incredibly efficient at burning the fuel. But the efficiency comes at the cost of energy. So it's just basic thermodynamics. You're going to burn things more efficiently, you burn them slower and fully. You're not burning them fast and incomplete. So you don't produce enough energy, and then it doesn't heat up enough. So it takes you longer to cook even. LPG is not a big deal, you just kind of crank up the power. You can just create enough power, there's enough BTU in there.
Well, strictly speaking, LPG has you can do Chinese cooking with LPG. You can cook in a wok with an LPG.
Yeah.
So there is a flame. Not barbecue, but
you can barbecue.
Yeah,
But you can come up with
come up with alternative ways to do it.
But you have to convince people that that food tastes the same, and that has become, I think, a lot of the approach, the way you cook becomes entrenched. It becomes part of the culture.
You have to convince the mother-in-law it tastes the same.
Yeah, it's like everybody has to agree.
This is the barrier, not the cook.
And then the other part that I found that was incredibly helpful is bringing social behavioral scientists is that you really do need to have a sustained message, having promotional. You have to promote this. You need to have cooking demonstrations. We had not only the cooking demonstrations to show how it is safe, and then we were doing monitoring. We actually came in and weighed the tanks to make sure that we're using them. And Tank is like, are you using the tank? Are you using it? Not using it. We did tank exchanges. Here you can actually see up there, you see that little red thing. It's by the biomass stove and also by the LPG stove. We had these temperature monitors, so we know when people are using them. And if they didn't use them, we say, why are you not using them? So we were continuously following up. So we wanted to make sure that we were actually having them used. And then we also created little posters that we give people and that kind of keep in mind that this is important. So basically, just to kind of understand some of our population, it is you can see that overall it's kind of a pretty poor population. I think the majority of them were earning under 250 soles. There's about $70 $70 a month. About 70% owned an LPG at baseline, but they were not using it on a frequent basis. I think that's the program, the FISA program, pushed them to buy an LPG stove, but they couldn't sustain the use of the LPG just because of the cost. And you can say about 50% had participated in FISA at some point. But the average age was about 50. We had a whole range between 20 to 64, and the average family size was about 4.
You have 94% electricity in the household.
Yes.
I thought that was one of your criteria for participation, that people didn't have electricity or very low.
Not for us.
Oh.
This is for FISA, for the
Okay,
fund.
sorry, exactly.
The fund did either no electricity or they use little electricity.
Okay.
Our main criteria was that you're burning biomass daily in your home. So you have a gross exposure in your home at least once a day. Most of these homes are burning it every day. So basically we're just gonna go through, I'm just gonna talk about the exposure reduction because we haven't finalized doing all the analyses of the outcomes. And I'm just gonna be talking about, this is the preliminary look. But the basic thing is that once we looked at our data and our compliance monitors, we're able to achieve 98% compliance in the first year, which is impressive. And not only that, it's like we were also able to reduce exposure substantially. So this is a box. These are box plots, and we're looking at 3 points in time at baseline month, which is pre-intervention, and then months 3, 6, and 12 post-intervention. And then here in the y-axis you have the concentration of particulate matter. That line 25 is the safety the safety guidelines from the WHO as to where you need to get to. Green is intervention, red is control. You can see that the distribution of data at baseline is pretty similar between both. And then once we provide the intervention, pretty much there's literally complete separation in the distributions. And that most of the intervention homes were at that level of as defined by the WHO. And those are the ones that we had in the kitchen. So we had monitors that were in the kitchen.
So this
people also carried monitors in themselves. But at 20, we had a monitor that was carried with them. You can see at baseline, it's the same, but also again same thing in the personal. You see complete separation. As a matter of fact, we're going to be below the WHO exposure for personal exposures. Yeah.
I mean, the previous figure I saw was a little funny because it suggested that the process of cooking, not the fuel, but the process of cooking is very clean. Whereas the next one, as a person who does all the cooking in my household,
Yeah.
Occasionally when I do certain kinds of cooking, I have to turn on the vent, and there are things that you cook
Yeah.
that put out a lot of stuff.
Yeah. You should be turning on the vent every
Yeah.
time you cook.
So
Doesn't matter what you
that
do.
one's more, strikes me as being more realistic than your first one, because
Yeah.
it says that even if you have a very clean cooking medium, the
Also,
cook is
but
going to
the
be
scales are
exposed to a
different
lot
too.
of.
The scales are different, but you can see
Okay.
that, but the point is that there's separation, and we were able to get people, their personal exposures are below the threshold that's considered safe. So that's actually we achieved
This one
a
is the previous
significant
one, this
reduction.
one's personal, 48-hour means.
Yeah,
and
so
the
that
other
means
one-
like the one that they're carrying,
And the other
and
one?
this is the kitchen.
Oh, the kitchen, okay.
Yeah, and you can see the scale is different. This goes up to 5,000 micrograms per cubic
So the
meter.
previous, the next one, the other one is what the cooks.
What the cooks was experiencing.
That includes the cooking.
Yeah, and you'll see that people they don't stay in their kitchen; they're walking in and out.
Yeah.
So there's going to be a difference in how they do it. And the same thing, you found that this is not, obviously we did carbon monoxide. You can see that same thing. We're able to achieve reductions in carbon monoxide, both in the kitchen and personal. And there's like full separation. And the one thing we actually weren't able to reduce was nitrogen dioxide. So we didn't think of this, kind of like it's, I guess, bad on us for not thinking about it. We think of LPG as a clean fuel, but it's a fossil fuel and it's burning other gases. And about, and you think of it, about a third of the homes have levels of NO2 that are being produced that are, 2/3 of the homes have NO2 levels that are being produced that are above the safety levels as defined by the World Health Organization. So as much as we're eliminating particulate matter and carbon monoxide, we're still producing nitrogen dioxide that could have important health effects, because nitrogen dioxide is also a gas that is inflammatory. So as soon as you breathe it in, it's going to cause inflammation, it's going to cause damage. So that's something that, this is something we learned, had we been smarter, we would have had a vent, and we'd have had them turn on the vent and use it continuously. But this is something that we didn't think about. Just and kind of last thing I'll say about this is that we do have, we've had a chance to look at some of the outcomes. I'm not going to talk about the health outcomes now. I think one of the things that we did see is we did calculations of time saving. So whether we used a survey or whether we actually did it with looking at our stove use monitors, we find that participants with LPG kind of spend about 5 fewer hours either collecting fuel or cooking than they control. So they had 5 more hours to use in something else. All of a sudden it's like, in a week you gain 5 hours, what will you do? That's you can use that for something, and that has value, and that and we're going to be looking at how it improves quality of life and income earning potential. Actually, Suzanne Simkovich has actually worked on this and has done estimates of like looking at the literature. We found very similar effects. It's about 7 hours.
It was
10 hours per week.
It was almost exactly on
Yeah, per
par with
week.
what we're finding on here, but there's only been 2 other studies that have been done using any objective measure of time and not just an estimate.
And she was able to do calculations with shadow wages in the countries where this was done, and what was the kind of the income potential
It's
income
about
gain?
an extra, depending on the high and low range, about 5 to 8% per month increase in income. But for a family like that's pretty substantial, given their level of poverty at baseline.
The cardiopulmonary and household air pollution trial has kind of led us to do a bunch of different offshoots as well. Now that we're done, we're looking at different strategies for field conservation. And Kendra Williams, who was a doctoral student when this work was done, is now a postdoctoral student in our group. We were able to get a grant from the NIH to actually look at different promotional messages to be able to get increased fuel use, and Susie Pollard's also being kind of engaged in this work, thinking about what it is that we can do to like improve sustained use of LPG. The other thing that we have a faculty member from the Department of International Health that came up with the use of a thermal cooker. So once you cook with it's Steve Harvey. So he said, like, why don't you use kind of a thermos where you cook and then you put the food in the thermos, and because of the thermodynamic properties of this thermos, the food will continue cooking and it'll stay warm during the day, and maybe that will allow you to conserve some energy.
I've got to add to that. This is what I have also been a little bit involved in thinking about. It's what in electricity business we call energy efficiency or demand side management.
Yeah.
We just don't focus on the supply side. We also focus on how to reduce the requirements, right? And that's maybe partly changing the ways you cook, but you get the recipes from the local people, or you put double-walled, pots so that the heat doesn't escape. No one really does it. This is all just dreaming. Okay, we really haven't got any, or even Insta pots or slow cookers, right? I'm mainly involved in electricity, so I'm thinking of it from that point of view. But you need to think of even in the LPG side, because for poor people, the LPG, as you found, is very expensive.
Yeah.
They're $70 a month. That's not a good income to do this, right? And so if they have demand side energy efficiency in cooking, then the need for the LPG will come down. Now, as I said, we don't have any success stories, or we don't have any experiments. But if you troll the internet, you find that women will say, I'm looking mainly at Africa, will say, I have a recipe, you can reduce the energy need by 30%, 40%, right? And there are people around whom I talk to once in a while, and they say, look, I can cook African way, but we use less electricity or use less energy. So at some point, we could be thinking of how to actually reduce, especially for the poor households, because as you found, they can't afford the LPG.
Yeah.
They can't afford it. You can give it to them, but unless it's free, at $70, there's no way. There's no way. $70 a month, no way they can do it.
I mean, countries that like tea, for example, the invention of the thermos has had a tremendous impact on countries that drink tea, because you don't have to cook hot water all the time.
Right.
Cook it in the morning and
Keep it warm.
Yeah, it's just a form of energy efficiency.
Yeah. Has anybody ever done a study of what the impact of energy use in Asia, for example, of the thermos? I mean, in 1850s they still drank. Well, in 1900s they drank tea, but they had to brew it
Every time.
all the time. But I don't know how you do it, but it strikes me as being quite substantial. Well, I guess if you look at Southeast Asia, poor countries, as they modernize and thermoses become more available. Certainly you go to rural areas and every household has a thermos.
True. And in Asia, like in Myanmar and Nepal and all, they use the rice cookers. And that's actually quite helpful because it's very efficient, right? And also you can have a time shift. This thing can be started before the peak time comes, right? Because one of the problems we face is meeting the peak demand. If everybody is cooking at 6 p.m., rice cooker keeps warm, right? You can start it at 3 and leave it, and it keeps it warm. So these are some of the thoughts that I've been thinking of as a consultant for the World Bank in terms of cooking. And
it'd be great to just.
I would love to be involved. Most
have a
of my
chance
time.
to think about
Most of
more
my
of this
time
because-
has been, of course, on the supply side of energy, but not on the demand side, and mainly on electricity. But I've been a close follower of all this cook stove stuff, and it's actually now turning out to be more important than electricity because we more or less figured out how to do electricity thanks to cheap solar panels. We can put them everywhere and we can make it work. And as you said, in India, everybody is 100%, almost everybody has electricity, but almost nobody is cooking clean, right? This is actually a bigger problem than providing electricity. So I'm now adjunct faculty at ERE. I'm an economist, card-carrying economist. I'd love to be involved.
Oh, that'd be fantastic. We need your card.
He mentioned the $70 for, the cost of LPG. The people at the end of your program, when they have to buy their LPG, are they getting the government subsidized LPG? Or
They can still qualify if they're eligible. I think most of these families are eligible. We actually found out that there's a clandestine market for these vouchers.
Yes.
Because they actually sell the vouchers for a little bit. They make money out of it. And they sell it cooking by mass. And we knew this was happening. Because and it's something that
India's famous. The World Bank is very unhappy about India's energy subsidies because they turn out not to go. They don't go to the poor, but the poor sell the vouchers.
So we found this, and actually when we knew that we're not using it, we approached them and said, for this study, how about we actually combine your vouchers with the. They were like, no way, this is like we use these vouchers, somehow they're like using it, whether they're trading it for chickens or for like crops or for some cash or whatever it is that's being used. So it's so definitely. And last thing I wanted to do, I know we're pretty much at time, but I wanted to just talk about this last study. This is the Household Air Pollution Intervention Network is a joint investment by the National Institutes of Health and the Bill and Melinda Gates Foundation. They put $30 million into this project, and this is a kind of a shared project. We have 3 principal investigators, Tom Clausen at Emory, Jennifer Beal at Colorado State, and me at Hopkins. And we're doing this study in 4 different countries. The main thing is that, as you know, all previous efforts in household air pollution intervention trials have failed, and we think that they failed because energy is not clean enough. So now we're using the same approach that we're using in CHAP, LPG stoves, and then providing continuous fuel, but in 4 different countries. We're doing it in Guatemala, in Rwanda, in Peru, and in India. And we're following, it's 3,200 households, 800 households in each country. We're enrolling households that have a pregnant woman, and then we're following the pregnant woman till they give birth, to get birth weight, and then we follow the child to look at growth and pneumonia. And then we look at 200 older adult women, usually the mother-in-law or the mom who's living in the house, and we're doing assessments of blood pressure. So we have kind of these similar eligibility criteria, and the idea is that we're providing continuous LPG fuel for 18 months, and our primary outcomes are birth weight, child pneumonia, growth, and blood pressure. But we have a whole set of different secondary outcomes that we're looking at, so it's a pretty extensive and intensive study. And the same thing, we're also using stove use monitors to see who's using what. But I think this study can also offer opportunities, especially now that we're getting to as we get closer to the end. We would love to be able to think about all the way from designing studies or experiments to think about reducing LPG use, or maybe thinking about how to be able to scale up some of our studies, or maybe even follow the participants later on and see if they have extended health benefits, in particular the children who are born in environments that are cleaner. So these children are now not exposed to the smoke in utero, and so we're thinking about following them for cognition and other health outcomes. So yeah, so this finally this is a word in Aymara. It feels like a garbled language, but actually it's a word in Aymara that says we should come and talk together. Okay. And that's basically I don't even know how to pronounce it. And, but this is a picture in Puno. These used to be old burial tombs of the Peruvian Indian communities of the zone that would just build these like circular tombs. So these are sacred places here. It's a kind of a place of rest, kind of overlooking the lake. So, all right.
So what is the timeline for this last study? When do you expect to have
results?
Yeah.
So we are more than halfway in enrollment. We're going to be done with recruitment in February 2020. Our first outcomes, like birth weight, will be done in June of 2020.
Okay.
So we're hoping that our publications will happen sometime in the late summer. And then we're following the kids, so an additional 12 months. So there's a year later, we'll get the rest of the results.
Okay.
So we're still about 2 years away from having all the outcomes. But I think this is the time to think about potential proposals and new grants and new ideas that we can kind of incorporate into follow up.
Excellent. Well, let's thank Will for a great talk. And if there are any more questions, I think we still have a few minutes.
Do you think the better environment will help the kids or children to solve the problem with obesity? Because I think it has become the bigger problem these days.
So let's see. What's interesting is that in the communities where we work, in rural communities in particular, the problem of obesity is less pronounced than in urban settings.
Yes.
I think it's not that it's not there, but you see it. Usually it comes in a little bit later, as the elderly become less mobile. Because you think of a rural farmer is always moving, and always moving. You chase like the silly goat that like went off the ledge and then go save it, or you walk 3 or 4 hours in the morning to get to the pasture. They're always moving. So, and we've actually done those measurements, and we see that they walk much longer than urban households, and they're always out there moving, and their obesity is, their BMI, their body mass index is lower. I think this becomes an issue in peri-urban communities, where you're entrenched in cities where you get into this poverty trap, being in a peri-urban community, still burning biomass, you don't have enough money, and I think the problem of obesity is more focused as to how you're eating, and also the lack of physical activity, which is kind of the biggest issue that we see.
It's an income issue. I went to a slum in Nairobi. World Bank has a pretty successful program there. You don't see obese people.
Because of the education?
No, they're too poor to buy so many, they can't just afford to buy calories, they don't just eat 3,000 calories a day. They still are poor, right?
Yeah.
They're living in very poor households. They still have, some of them have better houses. But if you ask them, do you have a fridge? They have electricity, legal or illegal, but they can't afford a fridge, right? So even if you give them a fridge, they can't afford to buy the stuff to put in the fridge, right? They're just buying small quantities every day. So they are really not, unless you hit a certain level of income, you are, as you said, they're moving around and they just don't have that much food to eat. So obesity is not really an issue that I have seen.
We're seeing obesity in like Lima, in our studies in Lima.
Right.
Obesity is a huge problem, and it's exploding.
Well, strictly speaking, Latin America is stuck in a middle income trap, and being middle income means that you can afford obesity.
Yeah.
Middle increases.
Yeah. Are there any obvious problems with extrapolating your results to urban settings, high density settings?
So the biggest issue with high density in urban settings is the ambient exposure. So if you live in a community around Beijing,
Yeah, or Bombay,
or Mumbai, or Chennai, where your ambient air pollution levels are 200 to 300 micrograms per cubic meter.
Right.
It doesn't really matter how much you reduce it inside the home. Well, I guess it does. You
It
go from
does.
1,000 to 200,
Yeah.
but you're
Well,
still
you get
above the
these huge
safety
peaks at 6 o'clock
limits.
in the
Yeah.
evenings, everybody's
It is-
cooking.
You're still above the safety limits, and I think it's the effects will be probably less pronounced just because of that exposure response curve. You know what constitutes safe air. It's probably somewhere between 50 to 75. When you're below that you get the biggest bang for the buck.
Yeah.
So I think that becomes a problem. In one of the studies that was just recently done in Ghana, it's it's called the GRAFS trial. There in Ghana, it's highly dense, and homes are right next to
Well,
each
there's
other.
rural and there's urban. Presumably,
Yeah.
you would find rather
Yeah.
substantial differences in the big cities in Africa and the countryside, presumably.
Yeah. So there are differences there, and I think it's that trial failed to show differences. For example, even though it's a kind of a clean type of intervention, it failed to show a difference in reduction in particulate matter. A lot could be is that environment, everybody's cooking, and you're still exposed. Like your neighbor's only like 2 meters away, and all that smoke from the neighbors coming into the house.
And your definition of health is basically blood pressure, all short-term effect, doesn't include cancer, for example.
So a
cancer
lot of
exposures.
these long-term, a lot of these hard endpoints take a while.
Mhm.
So death takes a while.
You don't have to-
You think about cancer, development cancer takes a while. Even the work that we do in lung function, COPD. COPD is a middle age, and we're talking 50s, 60s in age disease. So you have to follow people for 15 to 20 years. Even though it's accelerated, lung function declines accelerated, you can actually see that the lung function is dropping almost double the rate than those that are not exposed. It still takes a while to develop. So you need to have studies that go beyond 5 years. In a 5-year timeline, it's hard to look at it. So you're looking at intermediate outcomes. So blood pressure is a good intermediate outcome to look at, and you can measure it. It's easy to measure. Lung function we can measure. We know how to measure it. We can do symptoms, but if you want to do a true incidence study, first of all, you need large populations, and you need time. And so that's part of the issue. I think that's why a lot of the focus of air pollution studies in ambient air pollution, you can do it because what the governments have done a good setup of measuring air pollution throughout the decades, and you can follow people retrospectively. Okay, we've had data on air pollution for 20 years, and people are in this area living there. We can look at them 20 years, and the percentage will die, and percentage will develop stroke, develop heart attacks. You can look at it that way, but it's a little bit harder when you do population-based science. I think it's even in our household pollution study where we have 3,200 people, and we're looking at pneumonia as our primary outcome. We only had 8 pneumonia cases, so far. So it's I think when you get into population-based science, I think the part of the limitation is based on how is it that you follow your sample size, or you follow your participants.
Wonderful. This has been great. I learned a lot. Let's let's conclude now. We are just about to run out of time.
Okay.
And I'll take care of our guests. Thanks everybody for joining, and please join us for our next one. We'll have Ritam Chori from our economics department talking about firms and infrastructure grants in October. Thank you.
Thank you.